So, I'm not from Switzerland, but I think we should go. My name is Gabriel. I'm from Brazil. And
Rodolfo, from Brazil too.
it's hard to speak in Brazilian in English, but it's Rodolfo. I don't know how to speak in English. So we're a SUSE partner in Brazil, and we have some cases using Raspberry for business, and we like to show. And it's not a technical presentation, but there are three of us here. And if you have some technical questions, I'm here all day. I'm here all week. Also Rodolfo and Kleber in the room. So feel free to ask about technical details, and we will be a pleasure to show to you. So we have 5 years in Brazil, but I and Kleber works with SUSE since me 2009, and Kleber, I don't know, maybe 2000. Yeah. So we are open source guys. We work mainly with Linux and all software that is enabled to run on Linux. We have certified professionals in all SUSE products. Also for training, I'm a certified instructor also. Kleber is instructor also. We work with all products and make some other service or development to these products to enable more features or adapt better to the client. So we are mainly a service company. We don't have closed solutions. We work with services. So the first case is on GPA. We used Raspberries in the warehouses of GPA to enable dock operations. I don't know if dock, it's good to talk. Okay. So we enable dock operators to take a look in the shipment status in the dock. Okay. So GPA is the largest retailer in Brazil. They have 2,092 stores. They have 49 warehouse centers across Brazil. They are present in 23 states. They're a big company. And about the 49 warehouse centers, they also is the largest distributor in Brazil. It's the largest distributor group in Brazil. They have 140,000 employees only in Brazil. So the objectives of the project is to open a web page to inform dock operators about the shipment status and the time to the next shipment, and they will know if all the guys from the dock team are good to go, are delivering in time. Okay. This needs to open in kiosk mode, be simple to operate, because these are not tech guys. They don't work with computers, okay? To avoid operation and misconfiguration errors, we have to force, in this first step of the project, the configurations in a decentralized way. We are currently in a proof of concept, and they cannot expand too much. So we have to go decentralized in the first phase of this project. And we have to create some kind of automatic update in these units, and it have to be cascaded. So if one update goes wrong, we can stop the internet or block the updates in the latest units in this chain. Okay? So in Brazil, we have a regulator for telecommunications. So every single unit that you sell in Brazil have to be regulated. That needs to go under a process to make sure that the unit, the Raspberry, is using allowed frequencies in Brazil. Okay, so there's one company that create one process at Anatel. That is, it's the regulator. And they have exclusivity to sell this different Raspberry. It's a blue color, and they have the rights to sell in Brazil. So we have to use the units from this company. But it's mainly the same board that Raspberry sells outside the world, and there are no difference except the Anatel badge in the color of the board. So we work with these units. We support and deliver. Our main objective in the future, in the end of the process, is to deliver enterprise-grade Linux, okay, with SUSE. You have to go under security and compliance according to enterprise, using the same rules that other projects use on the company. And we bring the customizations to the SUSE image to the customer needs. The infrastructure, we don't have to bother about the Wi-Fi because the guys on the warehouse have scanners that use Wi-Fi, so we use the same. It has a good signal. These units consume, it's a low power, so it's not a problem. They bring a power cord from the roof in a straight line, okay? And they have no mouse or keyboard. It's only HDMI and a power and a television, okay? In the process, we mainly use Saltstack to everything, okay? So we use states to remove unused package to make a light version of SUSE for Raspberry. We have states to configure all the services according to network, NTP, and etc. We use special flags in the group to prevent data corruption. They have a switch at the Raspberry to on-off. They don't have keyboard. They don't have to a way to get a smooth process of power off. So we have to tune the group for this. And we have states to install and configure Google Chrome because it's better rendering than Firefox, and it's lighter than Firefox. And this states configures an URL through open in the first boot. Okay. So the image creation process, it's mainly create, get a fresh image from SUSE or OpenSUSE. And the first thing that you have to do is install a salt menu and apply those states that we create here, okay? We have to install salt menu as a masterless salt environment because it does not have a master. It works alone, okay? So we put inside the SD card the states, and salt works in a masterless way. It keeps refreshing those rules and keeps reapplying those rules every 2 hours. 2 hours. Every 2 hours, the salt at a masterless configuration runs a high stage, so they reconfigure it. They make sure that all configurations are in place. Okay, so we have here an SD card prepared. And we have to convert this on an image. So we make states to remove all the control files, all the registries from MAC address, network, and so on. And then we fill the free space of the image with zeros. So in this way, it's better to get a clone of this and then zip this. This is more compressible. But we now use another way. We reduce the partition and then makes a less image. But in this project, we are figuring out how to do this process, okay? So in this, we use it that way. So the project is currently on proof of concept. The customer like to see how the Raspberries perform, how is the durability of the hardware. It's cheaper, but in larger numbers, not so cheaper. And they have to make sure that it works to invest more money and get an infrastructure to have a centralized way to operate in the future, okay? So the next step is scale to 300 units, use orchestration with Saltstack in a master way, okay? And also with SUSE Manager. And using only SUSE Linux Enterprise now, and in the next project. So these are the kiosks on the warehouse. It's mainly a television with, here is the power cord going from, I don't know how to speak in American measures, or, but it's 15 meters power cord going from the roof to the floor. So they create this metal unit to accommodate the television, and the Raspberry goes on the television. And this is mainly in the Docker front. Okay, so they have 30 units at the warehouse at São Paulo. And the warehouse manager goes with goggles. Goggles, it's right, okay. And in the control tower, they look at all these televisions to make sure that all the docks are on the way, on the schedule. So here's the warehouse, and the televisions are right here. Okay, so this is the first case, and the next year we have to scale this to 300 units, mainly to cover one warehouse. They have 49. And they also sell televisions, so it's cheaper to So.
They interact with the system with touch screen.
No. There's one URL. There's one URL for each dock, so they don't need to touch in nothing.
Yes, the application is basically a web browser that refreshes the page every 30 seconds.
Yeah.
And show the information about that dock.
Yeah, and the operation in the installation customize the URL, and you're good to go.
No interaction.
No interaction.
No, in this case, no. So the second case is a digital signage for retail. We don't have the rights to use the name of this company, but it's smaller than GPA, but it's a huge retail in Brazil also. So in that case, we use mainly Raspberries to a digital signage project to take videos on the store and show panels and show images to internal communication of the retail. They have 290 stores. They have 1 million clients each day on their stores, and they have more than 20,000 employees. Okay, so the project conception, we already work with Linux, SUSE Linux. We have this open source digital signage solution called Zibo, I think. In Brazil, we call it Shibo. So it works in Linux. You have on server. You can schedule videos and images and different kinds of media. Okay, so it's open source, but they don't have open source clients to their solution. So we take this server, we understand the server, and we make our own client to work with this. Prior to the project, the customer are using Windows clients, Windows old clients on XP. Okay, so we developed a new client written in Python. Okay, and the first step, the first version of these projects are using nettops or old computers from store. Its units are used for register on the store, and they are replacing it, and we get this old crap hardware and gets a sled on here, and the client runs. But it's very old clients. They cannot even play HD videos. Okay, so this is our work. This is works. Okay, but it has a crappy image. But we are able to get 600 TVs on the stores playing media for the clients every day. So we manage this with SUSE Manager and Saltstack mainly. Okay. In the process, we created an image with, in the first boot, it only asks in each store and in which part of the store this television is, and it's mainly puts the host name to take in place what schedule has to run on this part of the store. So I already said that we developed the Shibo client using Qt and MPlayer as a video engine. We only support video and image capabilities because it's the main features that client needs. And we used QE to create this customized slash image. Okay. So when the operators boots this image, the first thing to do is join to SUSE Manager, so we can work on the central office with these clients. So the phase two is the mainly object is use Raspberry as a digital signage client. We have to use an external wireless antenna to boost the signal of Wi-Fi, because in this phase we are using Raspberry on the back office, where they don't have a structure for Wi-Fi because they don't have computers there and no clients also. So to reduce the costs, it's better to use an external antenna instead of get an access point closer to that point. Okay, we use Saltstack and SUSE Manager, and we want to use higher video resolutions. So we ported the Python Shibo client or Xibo client to use MX Player, because MPlayer don't have GPU rendering on Raspberry. So we adapt also the Python client to open web page, because they want to use this solution to inform the store before the opening the results from yesterday. So they open a BI page and show, and the manager goes under to the workers on their store and show the results from the last day. Okay, that's the kit for this project. We have a mini keyboard, a mini wireless keyboard, the power, the external antenna. We found this Anatel regulated antenna with 5 decibels. It's right to say decibels, okay? It's a very strong signal. We have case, a regular case. You can find this on the internet. We have a long cable, about 3 meters or 10 foot, okay? And we have this Raspberry Blue board and the SD card of 16 gigs. Okay, so we get one here if you want to take a look. So, the project execution. In Brazil, we are a very large company, very large country with fewer technical resources on the cities, okay? So it's very expensive to get support on the stores. So we have to keep this working to get access in a distance, remote access to these guys, okay, to these units. So we use a bounding module to keep the connection words working whatever happens, okay. So we create a bounding, we create a virtual third interface. We keep just one MAC address running, and we adjust this bounding to switch between 2 physical cards, the internal card and the external antenna. And they keep switching this in case you remove the external antenna, the internal antenna continues working. So it preserves also the connections on upstate. They freeze a little bit, but they can get running. So, and we used UDEV rules to make this switch. Also, UDEV are fired in every event. So the rules, and whenever happens in a hardware communication, UDEV review those rules and makes the third interface working. So this is technical details. We have one here and 2 Wi-Fis, and they are both connected, okay? So the one use one or another. So we have the bounding here. We using primary slave as Wi-Fi 2. It's external antenna because it's have a stronger signal, but the Wi-Fi 2 is here also. If this Wi-Fi comes out, this comes in, and everything works in the same way. So the problems using SUSE Linux for this project. We have only 64 bits version of SLAS-image for HASP. And that's a problem because the Raspberry Foundation only have 32 bits firmware. Okay? So the kernel of this version cannot work with Raspberry Pi firmware. So this results in we cannot use GPU to video rendering. So we have crappy video performance. Okay. So so we don't have a decent player in this architecture. We don't have the codecs, and we cannot use OpenMMX and MML functions on this. But we are hope that the Gen 2 guys makes an user land in 32 bits for a 64-bit version of the kernel. So we want to use this in the future and make maybe make available the firmware at SUSE. So we have to work with the Raspberry guys on the booth, okay, to take this in place. But it's a really new kernel, okay, and the Gen 2 guys they are mainly using the fresh version of everything. So we have to get this on enterprise level first and then use on the client. So unfortunately, we have to use Raspbian for video. Okay, in video places, we have to use Raspbian as a main source of our project, but we can use SUSE for video and web pages. Okay. So in this image, we made a configuration panel and a status dashboard, developed it with PyDialog. So if the video is running and the digital signage is running, you can use the keyboard, the wireless keyboard, and press Ctrl, Shift, and K, and this panel comes out. So the technician can figure out how is the signal, how is the playing, how is the host name, and every technical details. They don't have to log in, and takes a terminal to do that. Okay. We use Saltstack to orchestrate and deploy because we have to use SLAS and Raspbian together. So we use mainly Saltstack. Okay. And we use states to remove packages, configure the services, and it's basically the same process of image creation. It's the same from GPA, okay? But we have to use another things. We have to make sure in a remote way that the video is coming out. The OMX player uses a buffer inside the HDMI port, so you cannot, in a software way, get what is running. So we have to hack real VNC to get the image inside the buffer of HDMI, so we can make sure that the video is running in a remote way. Okay, we have a state to get this working. So I think we're good. Any more tech detail?
No.
Okay. Rodolfo is shy, so but he can talk with you later. So that's the panel that I said before. We used that on the terminal. We stop the digital signage process and make this available to the technician. They are in rollout process today. So we have a tech at this retail with telephone, direct telephone. The guy comes to the store, make the installation, and open this page and inform that we are running, make sure that the video is running, the process is okay, so after that, the tech can goes out, okay. So this is the player working at our office, okay. We cannot take pictures at the client, unfortunately, but this is a Raspberry here and our television on the meeting room, okay, working. So for future cases, what we want to use SLAS and Raspberry in the future. We want to use eSynga 2 is German. It's a German project. It's a fork of Nagios, okay. But they are on the version 2. It's not a fork anymore, but it uses the same process to get information. We want to use Raspberry as an IoT device to monitor environment. What is the environment? We can use Raspberry with a lot of sensors to take information. And we work very closely to iSynga guys already. We use iSynga on every customer that we can use, that they allow us, we use it. We use iSynga to get these guys monitored about the video, the signal of the wireless. We developed the plugins to enable a more efficient way to monitor this process. Okay, so we have the knowledge with iSynga, we have the knowledge with Raspberry, and we have the guys that can develop any monitor plugin. So we want to use these sensors to get information about the environment. But we need to make sure to use more robust, is a good word, more robust hardware to the environment, because this antenna that I don't know, okay, cannot work on the street, for example. It's not prepared to outside environment. So we have to work with these Chinese mainly sensors and see if it resists to the long term to work with that. Okay. And we also want to get a camera on our Raspberries inside the stores and get information about the customers. Maybe if they are looking what they are looking at the video walls, and which campaign takes more attention or not. Okay, so we want to use this also with scanning Bluetooth on the customers, because they are on the front, and we want to track if the customers looks at the campaign, the entire campaign. Okay, so this is another project in a very early phase inside the company, and we are trying to figure out how to do that. Okay, so technical questions we can make an QA right now, but with coffee is better. We are here all day and until Friday, so feel free to make questions to me, Rodolfo, and Kleber. Okay, we are here. Thank you. Any question? I have to repeat your question. He is asking to us about to use OpenSUSE with 32-bit version. That's mainly because we have OMX player on that time working on Raspbian smoothly, okay? And the customer have made pressure to we keep the project on the schedule. So we don't have time to port OMX player and so on. So we want to use the tumbleweed version in the next levels of the project. I have to repeat. We are looking for the sensors and the stronger hardware to outside projects, and we are in a very early process on this, but we are looking for, yes. And we use mainly Chinese components, or in Brazil we have these smaller sellers. We use that components to make experimentation on the lab, okay. But to create some more business product, we have to find those distributors and so on. But for the board, for the Raspberry board, we have to go under Anatel regulated. So if you want to use another ARM hardware, for bigger screens, for bigger resolutions, we cannot use this of Raspberry. We have to use another. But we have make sure that is Anatel regulated first. It's a long process. It had to be made every year. So we are a small consulting company. We are not a hardware company. So we want to make some partnerships to help on that.
Have you had many SD card failures?
Mm.
What do you do to mitigate that?
So we don't have failures in SD, but we are working with 4 months or 5 months. It's a very it's a very new project, but it scares me. Your question scares me.
I've been using Raspberry Pis in limited production, and that's the problem you'll have in about a 12.
Okay.
Depending on how much.
Okay. So we are using 16 gigs cards. It's very cheaper, so we can ship to the store another already installed image on that. We don't have any interaction in the first boot. We only have to choose the profile for that store if it's a back office or a front office television. But so the manager of the store can replace the SD card. And that is our plan to this.
I'll speak to you later about a better way.
Okay. I'm scared now. So we have trouble with mainly with file system corruption, but we make sure that journaling options are more stronger to avoid this with forced power off.
We have that same experience in the older project
Yeah.
using Intel that people just turn on or off on the switch.
Yeah.
And the file system was
Yeah.
corrupted every time. So
We-
we understood that there are some tunnels that we can do in journal filters of the X4 file systems that we solve that by change some parameters there. And we apply that on the Raspberry Pi too.
Yeah. This is a case from 2014 at Amsterdam. So the presentation is there.
Yeah. How about the other pieces of hardware, the Raspberry itself, the antenna, and the others? Do you have any hardware problem substitutions?
So far we are good.
How many these two projects? How many Raspberries do you use for these two projects?
On the first one, we used 30 units, and the second phase of the project, we have to use 300 units. Yeah. On the second project, we are in this month rollouting on 104 stores.
Production.
Yeah, production. And we already had about 80 stores running for months.
I think that was something new.
Okay, thank you guys.